In this video, we're going to look at solving proportions and equations that have fractions in them. Recall that a proportion is when two fractions are equal to each other. All right, this is what a proportion would look like. It states that two equations are equal to each other. Now, in this example, which one of these is proportional and how do you know? Well, there's a couple of different things that we could do to test for proportionality. One thing that we could do is try to simplify each fraction and see if they are equal. In this first example, 1/6 would simplify down to the fraction of 1/3. And 14/42, both of those numbers are divisible by 14. That also simplifies down to 1/3. So this example definitely does represent a proportional relationship. All right. Another thing that you could do is see how you get from the numerator of each fraction as well as the denominator of each fraction. If you do the same thing to the numerator and denominator, then these two ratios have to be equal. To go from 2 to 14, well, you would have to multiply by 7. And to go from 6 to 42, you again would have to multiply by 7. So that also confirms, because I did the same thing to the numerator and the denominator of the first fraction, it gets me to the value of the second fraction, that this is a proportional relationship. Right, looking at this example, again, I can put both of these to the test here. 5/8 actually doesn't simplify, okay? The only common factors that 5 and 8 share is 1. 10 and 18, those are both even numbers, so if I divide each of those by 2, that's going to give me 5/9. And my first fraction was 5/8. Well, they're not equal to each other, so this is not a proportion. Also, looking at my numerators here, if I went from a 5 to a 10, well, I would have to multiply by a 2. To go from an 8 to an 18, well, if I tried to multiply by 2, 16 does not equal 18. All right, so this again does not show a proportional relationship. 5/8 is not equal to 10 over 18. All right, so keeping this in mind, let's see if we can solve some proportions below. All right, in each example, I have an unknown value. It might be in the numerator, it might be in the denominator. Let's see if we can figure out what the unknown value is. All right, looking at this first example, I have 4/3 equal to x over 6. I want to figure out what the value of this x is. All right, and I know that these two fractions are equal to each other. So what I'm going to do, I'm going to see how I can go from the first denominator to the second denominator since they're both there. All right, so to go from a 3 to a 6, I would have to multiply by 2. If I do that in the denominator, then I need to do the same thing in the numerator. And if I do 4 times 2, well, then this means that that x must be equal to 8. 4/3 equals 8/6. Looking at this example, x over 14 equals 3 over 7. All right, we always move in the direction toward the variable, so I'm going to be moving in this direction this time. And I know both of the denominators. So how would I go from a 7 to a 14? Well, I would have to multiply that 7 by 2 to make it up to 14. Therefore, I have to do the same thing to the 3 in this numerator to come over to this numerator, multiply by 2. 3 times 2, this x must be equal to 6. In this ratio, in this proportion, I should say, 36 over m equals 12 over 5. Again, we move toward the variable. All right, this time I know both of the numerators, so I have to figure out how do I go from a 12 to a 36? Well, I know that 12 times 3 is 36, so I'll do the same thing in the denominator. 5 times 3 means that m must be 15. Finally, in this example, I have c divided by 8 equals 6. All right, well, any number by itself, any whole number is the same as that number over 1. So c over 8 equals 6 over 1. We always move toward the variable in this direction this time. So in the denominators, I have to figure out how do you go from a 1 to an 8? Well, 1 times 8 is 8. So I'll do the same thing in the numerators. 6 times 8 means that c must be 48. In my next proportion, I have x minus 3 divided by 3 equals x minus 5 divided by 2. I want to try to figure out what the value of x is. All right. Notice that I have x in each of my numerators here. All right. I have a variable on each side. I know both of the denominators, but I don't know which direction I should be moving, from the 2 to the 3, from the 3 to the 2. And also, it might not be intuitive as to how you might do that problem. Okay. Well, in order to solve this proportion, it would actually be helpful to turn it into an equation without fractions. All right, this would be a much easier problem if we didn't have the fractions here. In order to do this, we will need to clear the denominators. All right, if I'm going to change this into an equation without fractions, then I need to clear the denominators or get rid of the denominators. In order to do that, though, this will require us to determine the least common multiple of the denominators of the fractions. All right, what I'm going to do, I'm going to see if I could figure out what's the least common multiple of my denominators 3 and 2. Once I know what the least common multiple of my denominators is, it'll then be easier for me to clear the denominators. So let's first figure out our multiples here. What are the multiples of 2? Well, the first multiple of 2 is 2, and then the second is 4, and the third is 6, 8, 10, 12, 14, 16, 18, 20, etc. All right, those are the multiples of 2. We're just counting by 2. Similarly, we want the multiples of 3. So we're going to count by 3s. The first multiple of 3 is 3, and then 6, and then 9, and then 12, and then 15, 18, 21, 24, etc. What I want to know is, what is the smallest number that appears in both lists? That's called the least common multiple. And, all right, if I look at my two denominators here, or my two lists, I should say, the first number that I see that appears in both lists is the number 6. All right, so the least common multiple of 2 and 3 is going to be 6. All right, so why is knowing the least common multiple important? Well, because now that we have determined the least common multiple of the denominators, what we're going to do with that number, we can multiply both sides of the equation, both sides of our proportion, by the least common multiple. All right, when I multiply each side by 6, I'm actually going to be able to clear out my denominators. So let's show that. Okay, so it's an equation. Remember, whatever you do on one side, you have to do to the other. So I'm going to multiply each side by 6, which is the same as 6 over 1. Okay, and since my numerator has a couple of terms in each, so I'm going to just put those in parentheses. Okay, so let's look at the left-hand side first. All right, remember that when you're multiplying with fractions, before you multiply, you should see if you can simplify. If you have a numerator and a denominator with a common factor besides 1, then you can simplify early. And looking at this side here, I know that the numerator 6 and the denominator 3 have a common factor of 3. 3 goes into itself once, and 3 goes into 6 2 times. Now I can do something similar over here on the right-hand side. 2 and 6 again have a common factor. 2 goes into itself once, and 2 goes into 6 3 times. All right, so now when I do the multiplication, all right, well, my denominators are all 1s, okay? And so I can ignore the denominators. I'm just going to have on the left-hand side 2 times in parentheses x minus 3. And that's equal to, on the right side, 3 times in parentheses x minus 5. And now this is a much easier equation for me to solve. So again, after we multiplied each side of the equation by our least common multiple, we were left with this equation. 2 times in parentheses x minus 3 equals 3 times in parentheses x minus 5. This is much easier for us to solve. What is the value of x? Well, let's go ahead and figure that out. 2 times x minus 3 equals 3 times x minus 5. What I'm going to have to do on each side first is distribute. 2 times 1x is 2x, and 2 times negative 3 is negative 6, so the left is 2x minus 6. On the right, 3 times 1x is 3x, and 3 times negative 5 is negative 15. Now that I've simplified each side of the equation, I can start to move variables to one side. Let's subtract 2x from each side. If you subtract 2x from each side, then on the left, 2x minus 2x is 0, leaving us with negative 6x. And on the right side, 3x minus 2x is 1x, or just x minus 15. Now all I have to do to isolate x is add 15 to each side. And when we do that, on the right, we're left with x, and negative 6 plus 15 is 9. So the value of x in this equation is 9. It's very easy for us to check if we put 9 here. 9 minus 3 is 6. 2 times 6 is 12. 9 minus 5 is 4. 3 times 4 is 12. The equation works. So again, by clearing the denominators of our original problem, it turned into an equation that is much easier to solve. So what you're going to want to do if you want to try to clear those denominators is try to figure out what's the least common multiple of your denominators. In our next example, we're going to solve this proportion by clearing the fractions. All right, and remember what we did before. If I wanted to get rid of the denominators, I had to figure out what was their least common multiple. All right, so if I look at my denominators here, 5 and 6, all right, well, their least common multiple is actually going to be the number 30. All right, 30 would be the first number in a list of multiples for each number. So I'm going to multiply each side by 30 over 1. And I'm going to put my numerators here in parentheses since there's more than one term in each of those. And now I'm going to simplify before I do anything else on each side. 30 and 6 have a common factor of 6. 6 goes into itself once and into 35 times. And on the right-hand side, 30 and 5 have a common factor of 5. 5 goes into itself once and into 36 times. Now all of the denominators are 1, so we can eliminate or ignore those denominators. So now on the left-hand side, I'm going to have 5 times x minus 1 in parentheses equals, on the right, 6 times x plus 2 in parentheses. Let's now go ahead and solve this equation. We'll need to distribute on each side first. 5 times x is 5x. 5 times negative 1 is negative 5. And on the right, 6 times x is 6x, and 6 times 2 is 12. So 5x minus 5 equals 6x plus 12. Let's go ahead now and subtract 5x on each side. That means I have negative 5 on the left, and on the right, I'm going to have x plus 12. All right, when I go ahead and subtract 12 on each side to isolate x, that means that x is going to be equal to negative 17. Okay, so if I were to substitute negative 17 into each of these original fractions, I would get the same result when I simplify. Negative 17 minus 1 over 6 equals negative 17 plus 2 over 5. Negative 17 minus 1 is negative 18 over 6 equals negative 17 plus 2 is negative 15 over 5. Negative 18 divided by 6 is negative 3. Negative 15 divided by 5 is negative 3. So that works out. And I know that x equals negative 17. Let's look at an algebraic equation containing fractions. Our process for solving this equation is going to be similar to what we did with the last two examples. I want to try to make this an equation where there are no fractions at all, which means I'm going to have to clear the denominators. I have x divided by 3 plus x minus 2 divided by 5 equals 6. And remember that 6 is the same as 6 over 1. All right, so if I want to get rid of my fractions, I need to clear my denominators. My denominators are 3, 5, and 1. So I have to ask myself, what's the least common multiple of 3, 5, and 1? Well, that number would actually be 15. So what I'm going to do to each side of this equation is multiply by 15. Now on the right, where I have 6 over 1, I'm just going to multiply by 15 over 1. And on the left where I've got my two fractions here, I'm going to put that whole thing in parentheses and multiply by 15 over 1. All right, so let's go ahead and see what we can do here to simplify this equation. Now, 15 is multiplying everything in the parentheses. So what I'm going to have to do here is use my distributive property. All right, 15 over 1 is multiplying x divided by 3. Well, 3 goes into itself once and into 15 5 times. So this is just going to be 5x. All right. Now 15 has to multiply x minus 2 divided by 5. 15 over 1 times, in parentheses, x minus 2 over 5. All right, and again, I'm going to simplify here before I do anything else. 5 and 15 have a common factor of 5. 5 goes into itself once and into 15 3 times. So over here I have 5x, plus I'm going to add to that 3 times x minus 2. And that equals on the right side 6 over 1 times 15 over 1, which is just 90 over 1, or 90. And now I have a much nicer equation to work with. There are no fractions involved, all right? And I can easily solve this type of equation. I'm going to simplify the left-hand side first. I've got to distribute this 3 to these parentheses. So I'm going to have 5x plus 3 times x is 3x. 3 times negative 2 is negative 6 equals 90. So 5x plus 3x minus 6 is 90. Let's combine the similar terms, 5x plus 3x, to make 8x minus 6 equals 90. And now this is just a two-step equation. Let's add 6 to isolate the 8x. 8x is going to equal 90 plus 6, which is 96. And now if I were to divide each side by 8 to get x's value, I know that x is going to be equal to 12. Okay, so this became a much easier equation for me to work with after I eliminated the denominators. Okay, and again, you could do a really easy check to make sure that this worked. 12 over 3 plus 12 minus 2 over 5 equals 6. 12 over 3 is 4 plus 12 minus 2 is 10 divided by 5 equals 6. 4 plus 10 divided by 2 is 6, and 6 is 6. So I know that 12 must really be the answer to this equation. Let's go ahead and do some practice solving equations that have fractions in them. Remember, we want to clear the denominators by identifying the least common multiple of the denominators and then multiplying each side by that least common multiple. So in this example, we have 3x over 4 plus 1/2 equals 2x minus 3 over 4. My denominators are 4, 2, and 4. The least common multiple of 4, 2, and 4 is 4. So I'm going to multiply each side of this equation by 4. And again, that's the same as 4 over 1. Now, if I look at the right-hand side, this is actually really nice since this numerator and denominator are the same. Those just become 1s, meaning that the right-hand side is just going to be 2x minus 3. All right, what's going to happen on the left-hand side? Well, again, similarly, I've got to distribute this 4 to each term. So I'm going to distribute it first to 3x over 4. 4 over 1 times 3x over 4. This 4 and 4 are going to simplify to 1s. And so that's just going to leave you with the 3x. All right. But if I do 4 over 1 times 1/2, 4 over 1 times 1/2, 2 goes into 4 twice. So this 2 is going to become a 1, while this 4 would become a 2. And 2 times 1 is 2. So that leaves us with the equation 3x plus 2 equals 2x minus 3. Let's get the variables on one side. I'll subtract 2x from each side. That means on the left I have 1x plus 2 equal to negative 3 on the right-hand side. And then to isolate x, I just have to subtract 2. When I do that, x has a value of negative 5. Looking at this example here, number 7, w plus w divided by 5 minus w divided by 4 equals 19. This w has a denominator of 1, 19 has a denominator of 1. My denominators are 1, 5, 4, and 1. What's the least common multiple of 1, 5, and 4? Well, that would be 20. All right, so I'm going to multiply everything on the left by 20. and I'm going to multiply the right by 20 as well. When I distribute 20 to each term, 20 over 1 times w over 1 is just 20 times w for 20w. 20 over 1 times w over 5, 5 would go into itself once and into 24 times. So this would be 4 times w plus 4w. All right, and then minus 20 over 1 times w over 4. This 4 would go into 25 times. So that 4 would be a 1. That would be a 5. 5 times w. So minus 5w equals 19 times 20, which is 380. All right, let's go ahead and simplify this side over here, the left side. 20w plus 4w is 24w, minus 5w is 380. And 24w minus 5w is 19w, equals 380. So to get the value of w, I just have to divide each side by 19. And now I know that w is going to be equal to 20. In example 8, a squared divided by 144 equals 4 divided by 9. I have to see if I can figure out what the least common multiple is for 144 and 9. And fortunately, I know that it is 144. So I'm going to multiply each side by 144. All right, well, on the left, 144 simplifies with itself, leaving us with just a squared. And then on the right-hand side, 9 and 144 have a common factor of 9. 9 goes into itself once, and 9 goes into 144 16 times. So that means I have 4 over 1 times 16 over 1, or 4 times 16, which is 64. So now my equation says that a squared equals 64. What I'm going to do now is figure out what the value of a is. Right now it's been squared. If I want to figure out what the value of a is, all right, I'm going to have to do the square root of each side. Okay, the square root of a squared is a, and the square root of 64, well, I'm asking myself there, what value times itself is equal to 64? Well, that could be 8, but it could also be negative 8, because negative 8 times negative 8 is 64. So I'm going to say this is plus or minus, positive or negative 8. So there's actually two answers here. A could be equal to 8, or A could be equal to negative 8. Either one of those values of A would give you a true statement. All right, finally, in my ninth example here, x squared over x minus 6 equals 36 over x minus 6. Notice that your denominators are exactly the same. All right, so to clear your denominators, all you're going to have to do is multiply both sides by x minus 6. X minus 6. And now your numerators and denominators will simplify with each other, meaning you're just left with x squared equals 36. And now this example is very similar to what we had here. I'm going to have to take the square root of each side to get the answer. The square root of x squared is x, and the square root of 36 is going to be positive or negative 6. All right, so x could equal 6, since 6 times 6 is 36, or x could equal negative 6, because again, negative 6 times negative 6 is 36. In this example, we're going to take a look into the future. Right? You cannot fully do a question that looks like this, but you are building the foundation to these types of problems. This is the equation that you would actually see in algebra next year. All right? It says that x plus 6 divided by x equals negative 7. The process here would be the same as what we've been doing all video long. What we're going to want to do is try to make this so that there are no fractions at all in this equation. So right now, x is over 1, 6 is over x, and negative 7 is also over 1. What we're going to want to do to clear the denominators is find the least common multiple of 1 and x. And the least common multiple of 1 and x is x. So I'm going to multiply each side of the equation by x. All right, and when I do that over here on the right-hand side, x over 1 times x over 1 is really just x times x, and that's repeated multiplication, so that would be x squared. All right, then I have to do x over 1 times 6 over x. This x in the denominator with this x in the numerator would simplify to 1, leaving you with plus 6. And then it's going to be equal to, on the right-hand side, negative 7 over 1 times x over 1, or negative 7 times x, which is negative 7x. All right, so your equation now would say x squared plus 6 equals negative 7x. What we're going to do now is get all of the variables on one side, which means I'm going to move this 7x over here by adding 7x to each side. All right, when I do that, x squared can't combine with 7x because the denominators are different. 6 can't combine with 7x because a variable term and a constant can never combine. So this left-hand side is going to say x squared plus 7x plus 6, and then the right side it's going to be equal to 0. All right, and now this left-hand side is what is known as a trinomial. A trinomial is a polynomial that has 3 terms, 1, 2, 3. In order to solve this type of equation, what you would have to do is something called factoring the trinomial. And the way that we're going to do that, we're going to multiply two binomials to make them equal to that trinomial. All right, well, I'm going to start each of the binomials with an x. And what I'm going to do, I'm going to look for factors of 6 that are going to add up to 7. And the factors of 6 that add up to 7 are 6 and 1. And so if I have x plus 6 times x plus 1, that's going to be equal to x squared plus 7x plus 6. And so now x plus 6 times x plus 1 equals 0. Therefore, that means that x plus 6 could be equal to 0, or x plus 1 could be equal to 0. So if x plus 6 equals 0, we would subtract 6 from each side, meaning that x could be equal to negative 6. Or if x plus 1 was equal to 0, we would subtract 1 from each side to get that x could be equal to negative 1. These are the two answers to this equation. X could be equal to negative 6, or x could be equal to negative 1.